All right, today we are going to learn a new method to solve systems of linear equations. Now we actually already know two ways to solve them. One of them is by graphing, which we can see below. I can graph the first line, which is in slope-intercept form. It has a y-intercept of -3 and a slope of 1, so I can go up 1 and right 1. Up 1, right 1, up 1, right 1. That's my slope, so that I can graph this line. I can also graph the second line because it is also in slope-intercept form, but this one has a y-intercept at 1 and a slope of -3, which means I'm going to go down 3, right 1, down 3, right 1, and I would get this line. So that's by graphing, but the solution is actually where they intersect. So if I want to know the solution, I need to look at where they intersect. And that point is at 1, -2. So when we find that point, let's just remind ourselves what we are finding. We're finding an x value and a y value. So I know x is 1 and y is 2. So this is by graphing, but there's another method we've also learned as well, and that was called the equal values method. And that's when we see that if we have two equations and they're both equal to the same variable, I can make them equal to each other. So for both of these, we see they are both equal to y. So then I can make them equal to each other, meaning I can say x minus 3 is equal to -3 plus -3x plus 1. And then I have an equation I can solve. So maybe I might want to add 3x on both sides. And then we'll see we get 4x minus 3 here. And all we have left on the other side is 1. Add 3x, or add 3. And we have 4x is equal to 4. Divide both sides by 4. And x is equal to 1. So as we can see, this is the same x value that I got in my intersection. Well, now that I know what x is, I do also need to find y using this same method. So I need to choose one of the equations that I started with. I'm going to choose the original one, which was y equals x minus 3. And now that I know what x is, I know x is 1. I can continue to solve for y. 1 minus 3 is -2. So I have my solution, which is the same as the y value there. My solution is 1, -2. So we have the graphing method and we have the equal values method. So today we are going to learn a new method called the substitution method. So what do you think the word substitution means? So when I think of substitution, I think of replacing something. So replacing. And there's also a key word in substitution, that's substitute. So replacing and substitute are what I think of. If you have other words you thought of, feel free to put them as well. So let's look into this money example, and we see here that $1 is equal to 4 quarters. And 1 quarter is equal to 5 nickels. So it might help if we label this. So we have a quarter here, and we know that it is equal to 5n. This is also a nickel, which is n. And then this is $1 here, which we also know is the same as 4/4. We can also label here that we know this is 1/4. So we can substitute Q in the first equation. So this is the first equation, so that it becomes $1 is equal to 4. Well, I know what Q is equal to. If I look right here, I know Q is equal to 5N. And that is going to simplify to $1 is equal to 20N. Or in words, I can say $1 equals 20 nickels, right? That's what N is supposed to be. And if I had $1 and change, it could definitely be in 20 nickels. So yes, this is true. This is called substitution method because we replaced 5 nickels for a quarter. So that's the money example. Like, we can replace certain coins for other things, but we can also do something like that for variables. A new method called the substitution method can help us solve the system below. We have 2 equations for our system. We have y equals negative x minus 7, and we have 5y plus 3x equals negative 13. When we use the substitution method, we need to have a variable x or y isolated. Which equation has a variable isolated? Write it here. So when I look at the equations above, I see this one has y alone on the left. Let's write it. Y equals negative x minus 7. Step 1, what variable is isolated? And looking here, y is the one that's alone. What is y? The expression equal to y. When I read it as y equals negative x minus 7. So the expression is equal to negative x minus 7. Step 3. Step 3. We know what y equals. We can substitute negative x minus 7 into y for the other equation. So then what I'm going to do is I'm going to copy down the other equation right here. I'm going to write 5y plus 3x equals negative 13. Then I'm going to substitute. Well, I know what y is equal to. I know y is equal to negative x minus 7, and I'm going to substitute that into y. So instead of y, I'm going to put parentheses. And I'm going to write negative x minus 7. And since I see that 5 outside of those parentheses, I'm going to distribute it. So distribute 5. That's going to give us negative 5x minus 35 plus 3x equals negative 13. Now we're going to combine like terms. So that means I can combine the ones that have x's. So I can combine negative 5x and positive 3x to get negative 2x, and then I have minus 35 equals negative 13. And so looking at this equation, what I now have is I only have one variable, which is x. So I'm going to solve for the variable x. Let's add 35 on both sides. I have negative 2x is equal to 22. And then I'm going to divide both sides by negative 2. And I have x equals negative 11. I found x. Step 4, now we know x is equal to negative 11. We can substitute negative 11 into x for one of the original equations and solve for. Well, if I know x, the last thing I need to now find is y. So if I look at the equations that I have above, I think that it would be easiest to use this equation. Y equals negative x, but I'm not going to write x because I know what x is, minus 7. I know x is negative 11. So now we're going to continue to simplify that out. Y is equal to, what, 11 minus 7, which is 4. So I have a solution because now I know x and y. I have to have both. I know x is negative 11 and y is 4. So my solution is negative 11, 4.